Today we're going to look at the graph of y squared equals x. Now you might be saying, well, if I was to rearrange that to make y the subject, I'm going to get y equals plus or minus the square root of x. So what's the difference? Well, with this one has an upper and a lower arm. This one is the whole parabola. So this is a parabola that's sitting on its side. So let's have a look at the general graph of y squared equals x. Let's look at some points. So if I was to plot this graph, what I find, and I'm just going to draw the basic one, what I find is that it looks like this. Okay, so it's a parabola on its side, where here, this turning point of the parabola is the value hk, which we're used to in other types of functions that we've looked at. And if we look at some coordinates, well, let's pick the coordinate when y is 1. When y is 1, 1 squared is 1. So, of course, that's the first coordinate. When y is 2, 2 squared is 4. Okay, but we also need to look at the scenario of negative. Well, what happens when y is minus 1? Minus 1 squared is 1. So, of course, there's the x coordinate at 1. It's there. Let's look at the situation when y is minus 2. Minus 2 squared is positive 4. So again, there's the coordinate there. Now obviously this needs to be in order. I'm obviously just drawing a rough guide with some coordinates on it. So obviously this would be 5, 6, 7, 8, 9. Let's go to 9. 3 squared is 9. So the x coordinate is 9. But also when minus 3 is squared, you get the x coordinate of 9 as well. So this produces this graph called y squared equals x. So when I was talking about the upper and the lower arm, if we're looking at just y and the positive root x, that's just this arm here. So this is the positive root x. And if I'm looking at this arm of the graph, I'm actually looking at y equals minus root x. And I actually discuss this type of graph in more detail, or separate the upper and the lower arm in much more detail in another video. Now let's look at transformations of this graph. And as with most functions that we've studied, this has a general equation. So if this graph is transformed, we can say it's transformed in this. Y minus k all squared equals a squared bracket x minus h. Now this is the general transformation of these graphs, where k is the vertical shift, h horizontal shift, and obviously a is to do with how far, or the dilation factor, how far away it is from the x-axis. Now let's have a look at trying to plot one of these graphs, or how to sketch it. I should say before I go into an example that of course the coordinate of hk will be the coordinate of that turning point, which of course on that graph is on its side. So it was 0, 0 on the original y squared equals x. Alright, so let's have a go at doing an example. Let's sketch the graph of y minus 4 all squared equals, and let's not have an a value, let's go x plus 3. Now, as I always do, whenever I sketch a graph, I put 3 headings. The first heading should be, well, what's the x-intercept that occurs when y equals 0? My next heading is, well, what's the y-intercept that occurs when x equals 0? And my final heading is to do with a feature of the graph. In this case, it's hk. What's the value of that turning point? This can tell us whether there are actually any y-intercepts or not. Because if the turning point is to the right of the origin, there aren't going to be any y-intercepts. Let's have a look. So to find the x-intercept, I'm going to sub when y equals 0 in here. So I'm literally just looking at this form. Oh, I'll tell you what we can do. We can work out what h and k is first. Just be aware that k is here and h is here. So we have to reverse the sign of those. So h will be minus 3 and k is positive 4. Therefore, we know the coordinate of that turning point of the parabola is at minus 3, 4. Now I need to go on and find the x-intercept, so I'm going to sub that in here. We get 0 minus 4 squared equals x plus 3. Minus 4 squared is 16. Add 3, subtract the 3, gives me the x-intercept is 13. Let's go on to the y-intercept. We've got y minus 4 all squared equals 0 plus 3. So that just equals 3. So what I can do is I can square root 3. Now when I square root 3, obviously get the positive and the negative. Then we add 4. So y equals 4 plus or minus root 3. So I have my two y-intercepts plus or minus 4 plus or minus root 3. When I sketch this, I'm going to sketch it. So let's put our axes there. I'm going to get my idea. The turning point's around here, but it cuts the x-axis at 13. So I've got to have a sort of smooth graph like that, which is continuous. Now let's put the points on here. Turning point is at -3, 4. So here's 4. Our first y-intercept is at 4 plus root 3. And our second y-intercept is at 4 minus root 3. And then this x-intercept is at 13. Now usually you'd put a title, put the title that this is the equation of the graph. I'm now going to do a second example. Okay, here's my second example. Now what you'll notice is that there's y's, there's squares, there's x's, but it's not in this form. So we need to rearrange it by completing the square on the left-hand side. And obviously whatever we do to the left, we have to do to the right. So I want to make a perfect square on this side. So in order to do that, I need to add half the coefficient of the y, which is 1 squared. So I'm going to add 1 squared to both sides. 1 squared is 1. And I need to add it to the right-hand side as well. This now factorizes perfectly to give me a perfect square. Well, y plus 1 all squared will be that. And on the right, I've got 2x plus 4, which can also be factorized by pulling the 2 out. So if I pull the 2 out, I get x plus 2. That's now in this form here, where we can see that this is the value of k. Obviously, k will be -1. This is the value of a. So a has a dilation factor of 2. And -2 is the value of h. Now, if we're going to sketch this graph, we should always have the same headings. We should have the x-intercept. We know that occurs when y equals 0. The y-intercept, which occurs when x equals 0, and then our value of hk, which we've just worked out, is -2, -1. So that's our coordinate of our turning point. So let's go ahead and do that. When y is equal to 0, we get 0 plus 1 squared equals 2 bracket x plus 2. Solving that, 1 squared is 1. Dividing then through by 2 is a half, equals x plus 2, and then solving that gives me -3 over 2 equals x. So that's our x-intercept. Okay, let's find the y-intercept. So let's sub x equals 0 into here. You get y plus 1 all squared equals 2x plus 4. Let's just do that. Subbing in 0, of course. 2 times 0 is 0, plus the 4 is 4. Square root 4 is 2, and then of course subtract, plus or minus 2. Subtract the 1 gives you -2 minus 1, which is -3, or -2, or +2 minus 1, which is 1. So your two y-intercepts are -3 and +1. Now all we've got to do is sketch it. I'll clear some space. Okay, so I've obviously jumped ahead and I've sketched it with our y-intercepts 1 and -3, x-intercept as -3 upon 2, and our turning point, which was -2 minus 1 hk. And that's everything you need to know.